Okay, welcome to this lesson on quadratic equations. Today we'll look at two kinds of quadratic equations in the form of y equals to plus minus x minus h times x minus k, which is the one you see on screen. And the second one will be y equals to plus minus x minus p bracket square plus q. So before we begin, I think the best thing we can do is whenever we're given graphs, given quadratic functions, we should actually plot them. So how on earth does this work? How can we infer information whenever you're given such a quadratic equation? Okay, so for this type of graphs, if I plot them, you realize that the x-intercepts are, okay, I'm just going to write the x-intercepts here. Maybe I'll just write it here, -1, 0 and 5, 0. Okay, next you see here that this is the x-intercepts are 2, 0 and 6, 0. Okay, now I want you to compare with the values of h and k of each of the equation as I'm doing this. So we do the same for this. So this is 7, 0 and this -7, 0, if I'm not wrong. Is it? Yes, correct. And we have -3, 0. Okay. Subsequently, we have negative function graphs, so something like that. It's quite huge, but don't worry about it. We're gonna look at the x-intercepts first. Alright, so we will have -10, 0 and 4, 0. And finally, we have this graph over here, which has the x-intercept through the origin. So there will be 0, 0 and 8, 0. Last but not least, our final graph here, it has a function of -3.5. Sorry, not function, x-intercept. Why am I say function? And the other would be 9, 0. Okay, now looking at the x-intercepts, okay, can you see a relationship here between h and k and the x-intercepts? Okay, so if we were to see, this is +1, but this is -1. This is -5, this is 5. Okay, so we can actually compare with the original equation, which is y equals to plus minus x minus h x minus k. We can easily deduce what k and h could be whenever we are given. So when we identify what's k and h, that would actually tell us that these are our x-intercepts. Correct? So what do I mean by these are our x-intercepts? Okay, let's use the first one as our example. Okay, we can find the x-intercepts very easily using this method. Okay, so the first one, h would be -1. Isn't it just the x-intercept? If I compare with the original x minus h, x minus k, and k will be 5 here. Okay, for the second one, this will be 2 and this will be 6. For the third one, okay, in comparison with the original equation, okay, so if I were to make this x minus, it will be x minus -7 and x minus -3. Subsequently, this will be 4, -10, and this will be 0. Why is that 0? Actually, this can be written as x minus 0 times 8 minus x. Okay, it can be written like that. So it is 0 and 8, and this would be -3.5, 9. So actually, once I give you an equation like that, you can actually just infer straight away without even plotting any graphs the x-intercepts of the function. So this is pretty neat, right? It's just a shortcut way to do so. And of course, we need to identify whether is it minimum or maximum point. So minimum point means it's the lowest point of the graph. So if we look at this, there is a lowest point of the graph, right? So the lowest point of the graph is in fact this over here. Okay, I'm not really going to care about the turning point for now, but I'm just going to identify whether is it minimum or not. So this is minimum, right? Minimum point, because it's, and how do I tell it's minimum? When the quadratic equation is positive, that means there's no negative in front. Okay, the second one is also minimum. Okay, the minimum point, that means the lowest point. Okay, the y coordinate of the other points will always be bigger than the minimum point. That's the way we look at things like that. Okay, and last but not this one, if I'm not wrong, should be minimum as well. Yep, this is minimum. And finally, we have a one with a maximum point. So maximum point means this is the highest point it goes on the graph. Okay, so that is given when you see a negative sign in front right here. So this is maximum. Last but not least, these the next graph may look like that there is a minimum point, but in fact it's actually a maximum point, because if you rewrite the equation, I can factor out a factor of -1, and you will have negative x times x minus 8. Alright, so this is still maximum. So please don't, it's very important to check, whether you can factorize out -1, and that will really help. So last but not least, this one over here is definitely maximum point. Okay, so with that, we can actually figure out the line of symmetry. Why? The line of symmetry is simply the turning point, and for a graph like that, it's simply at the turning point, right? And it will be just the x coordinate. And one thing very beautiful about the line of symmetry is that it's always in the right smack in the middle of the x-intercepts of any graphs, right? Of any graphs that has two real solutions. So in this case, let's look at x plus 1 times x minus 5. The x coordinate here of the turning point is 2. But can we actually get 2 from that? Okay, as I said, it is in the right smack of the middle of the turning points. So what I can do to find is, I'm just going to take the x-intercepts, add them together, and divide by 2. Okay, I will actually get a value of 2. Ta-da! It is just the x-coordinate of the turning point. So the line of symmetry is just the x-coordinate of the turning point, and you do that by adding, okay, the x-intercepts together and dividing them by 2, because it's right smack in the middle. It's right smack in the middle. We can always do this, alright? So if you don't believe me, let's try for this. Okay, the turning point is 4, and what do I get? I will still get 4 here. Okay, what about this graph over here? Okay, what's the coordinate of the turning point? It's -3. Okay, so let's do it. X equals to -7. Sorry, this is the wrong graph. It's this one. Okay, yeah, this turning point here, it's -5. Okay, -7 plus -3 would simply give you -7 minus 3. So this will give you -5. Hey, it's the same. Next we have this over here. Over here, what's the turning point? It's -3 as well. So let's just try x equals to -10 plus 4, which actually gives you -6. -6 divided by 2 is -3, and we are on a roll. So here will be x is equals to 0 plus 8 divided by 2, which gives you 4. Let's check. Okay, what's the x coordinate of the turning point? It's 4. So yeah, this is a very easy way to find your line of symmetry and your turning point. So last but not least, over here, x is equals to -3.5 plus 9 divided by 2, and this gives you 2.75. Okay, so what can we make some conclusions of a general equation in the form of y is equals to, in this case, this is positive, right? So x minus h, x minus k. We can deduce that one of them here, one is h and one is k. H and k can be negative or positive integers in this case. And the turning point here, okay, the turning point, let's mark it, write this, the turning point. This is the turning point. Okay, the x coordinate is simply equals to h plus k divided by 2, and in this way we can find the line of symmetry. I'm going to draw the line of symmetry. this is also in fact just x equals to h plus k divided by 2. Alright, so that's about it for this type of graphs. This kind of graphs of y equals to plus minus x minus h x minus k. For the negative way of this graph is just the opposite, but everything still stays the same. Alright, so that's all for these type of graphs. See ya.